Hello, it's Nehemiah from Special Science School. It's physics time. How do we do with physics? We had a lot of students that say, well, physics is hard. There is a lot of calculations in physics. And because of that, when they see the physics teacher coming into the class, they say, well, I want to go home because I don't want to listen to physics. I want you to pay attention to this class. Just listen, one time, listen to this class. The aspect of physics, for you to understand it, you need to take it step by step, poco. You need to apply just little application of mathematics in it before you can fully understand it. And what we're going to do in this video is to take every concept as easy as possible. So the first thing to learn in this video is the definition. The next thing to learn in this video is the difference between the fundamental and the derived. Both quantities and units. We're going to look at both physical quantities and units. So, we're going to look at the definition. One, we'll look at the difference between fundamental, derived, physical quantities, and unit. Let me take it in the way you understand. We'll look at the difference between fundamental quantities and derived quantities. Difference between fundamental units and derived units. Then we're going to do some solution to mathematical expressions. So that's the three things we'll be looking at today. I want you to be confident in yourself. When they say physics is difficult, because this is a year one course of physics, this is the first thing you need to learn about physics. Why do you need to learn measurement and units before you begin to study every other aspect of physics? I want to tell you there are other branches of physics, but the branch of the physics that we're dealing with today is classical mechanics. We have geophysics, we have nuclear physics, and then optic physics and the rest. But what we are dealing with today is classical mechanics. And one of the introductory topics of classical mechanics is measurement and units. And then if you look at the definition of physics, physics studies matter. Physics studies matter. Just underline the word matter. Now, physics does not just study matter, but is studying the measurement of matter. So physics is trying to measure matter. So we have measurement. So if you are trying to measure something, I think you're going to use a particular apparatus to measure it. If you want to measure maybe water, for instance, you're going to use some gallons of water. So the gallon, 1 gallon is the unit of measurement of that water. You talk about 1 bag of rice. You talk about 1 basket full of orange or pineapple, anyone. Or when you want to measure, there is a apparatus you use in measuring. So in physics, the apparatus we use in measurement is called physical quantities. So we have it over there. Physical quantities. So now, what is physics? Physics is simply the science or a pure science that studies the measurement of matter with the use of physical quantity to ascertain the accuracy of its measurement of the matter talked about. Or let me give it in a simple term. Or I'm going to give it in 2 terms, simple term and a complex term. So you take any of those, it's still correct. So physics is a study of matter. It's a study of the measurement of matter with the use of physical quantity. Studies matter, measurement of matter, measurement of matter. Are you writing? Physics is the study of the measurement of matter with the use of physical quantity, or the calculations of matter with the use of physical quantity to ascertain its accuracy. Whichever one is still correct. So let's go to what we have for today. Let's get to the board. All right. So the first thing to do is that before we begin to go to the fundamental and derived quantities and units, please look at me. Just look at me. If you say that the temperature of my body is 37, please, does that make sense? No, it doesn't make a complete sense. But if I say the temperature of my body is 37 degrees Celsius, that will make a lot of sense. If I say the distance from the school to my house is 20, does it make sense? No. But if I say 20 meters, if I say 20 meters, it shows me or tells me, oh, it's talking about distance. If I say 37 degrees Celsius, that tells me, oh, he's talking about temperature. What if I say 30? How many, what bags of rice is there? You just look at the word. What bags of rice are there? You can say 30 bags of rice. So 30 bags of rice. Or when they say, what's the weight of your body? What's the weight of your body? And then you say 40. No, you will say 40 kilogram. You can notice that the unit, this is what we call unit in physics. This is what we call unit in physics, kg, and then the bag there can also be called unit. But meanwhile, the physical quantities, for instance, is the velocity, the mass, the time, the acceleration, the impulse, the pressure, and a lot, which we'll be discussing today. So if they ask you, what are physical quantities? Physical quantities are all those things like the velocity, mass, time, pressure, length, electricity, luminous intensity, area, density, work done, force, momentum, PD, potential difference, kinetic energy. All those things are called physical quantities. And if you are new in physics class, I don't want you to be afraid. All these things I'm naming, I'm going to tell you how to know them in this class. And if you have been attending physics class, but physics is difficult for you, you just need to pay attention, and then we unravel the solutions to all that we have on board. So now I take that again. If I say 37 degrees Celsius, that's what makes sense. If I say 20 meters, 37 degrees Celsius from the temperature of my body, 20 meters the distance from the school to my house, makes sense. 30 bags of rice to ascertain the accuracy of the measurement of the quantity of rice that I have over there, and then 40 kilogram, that is the weight of my body. Okay, let's talk about the fundamental quantities and derived quantities. If you look at the word fundamental. Now, the word fundamental means basic. The word fundamental means basic or means independent. If something is independent, it means it can stay on its own. And then we have fundamental quantities. These fundamental quantities are quantities, or they are basic quantities that are independent. They can stay on their own. They are independent of other quantities. I take that again. Fundamental quantities are basic quantities that are independent of other quantities. And then if you have also the units, we have fundamental units too. So fundamental units, let me write it very well so that you don't get it confused. So fundamental units are the basic units or independent units too. Fundamental units are basic units or independent units which do not depend on other units. They are independent in the sense that they don't depend on other units. Now let's give it in the way that you understand. Fundamental, basic, and independent. They are quantities that are independent of other quantities. Because we have so many quantities, but we have the fundamentals, the basics, the primarily, of those quantities. Then we have the units. We have the fundamental, the primarily, the basic of those units. They are independent of other units. They are basic units. That's correct. They are independent of other units. That's correct. And then the quantities also. Now let's go to the table where we can classify the fundamental quantities. Let's say we have this table. All right. Now, in this table, we're going to be having the fundamental quantities. Let's use FQ for fundamental quantities. Then we have the mass. Don't forget the measurement. Don't forget the units, all right, or the symbol or the unit. Now, mass is one of those, and mass is, let me give you all of those before I give you the measurement and the symbol or the unit. Now, we have mass, we have length, we have time, we have electricity, we have amount of substance or temperature force, we have amount of substance, we have luminous intensity, I take that again. It's up to 7. 1, 2, 3, 4, 5, 6, 7. Oh, that's complete. 7 of those. We have mass, we have length, we have time, we have electricity, we have temperature, we have amount of substance, luminous intensity. These are the fundamental quantities. Now, the unit of measurement for mass is meters. And then the symbol is M. Oh, sorry. The unit of measurement for mass is kilogram. And the unit is kg. The unit of measurement of length is meter. And the unit is m. The measurement of time is seconds. And the unit is just like this, seconds. The measurement of electricity, or the terms of measurement of electricity is ampere. And the unit or the symbol is A. Then we have temperature, which is Kelvin, and then we have K. Over there, we have mole, amount of substance, also mole here. Then we have candela, and over here, we call it CD. Now, if you look at this board, you'll find out that all these listed quantities, remember I told you physical quantities, examples, velocity, mass, density, but the major one, the basic one, the fundamental one, is the 7 we listed on the board. You have to find a way to know that these are the 7. But meanwhile, this guy, which is the mass, the length, and then the time, which is called in physics MLT. Wow. So these MLT, mass, length, and time, they are the fundamental or fundamental. If you must not forget any fundamental quantity, that should be mass, length, and time. Well, that doesn't mean you're going to forget the rest of those. But if you're not going to forget any fundamental quantity, that should be mass, length, and time. MLT, which is the unit of measuring dimension quantities. But that's not what we have for today. Let's stay with what we have for today. And do you know that every aspect of physics, that's why you need to pay attention to this video. Just look at me, pay attention to this video one time. Every aspect of physics has to do with quantities, physical quantities. There is no aspect of physics anyhow, not the aspect of physics in the world, not the thing in the world, according to are concerned with physics that don't deal with physical quantity, not a thing in the world. Now, let's go to derived quantities. So for the derived quantities, I want you to pay close attention to everything we're going to discuss over there. So over here, we have for the derived quantities, what I'm going to do is that let's put those quantities over there. Let's put it there, and then let's solve the problems over here. So we have this board, Let's try to manage the board because we have plenty of those. Let's look for a more better ink. All right. So now we can have the derived quantities now. Derived quantities. Then we have the measurement, solution. The solution, then we have the units or the symbol. Let's take the first one. We have area. We have volume. We have density. Let me write it very well. We have density. We have velocity. We have acceleration. We have force. Let's write it well. We have momentum. We have impulse. We have prayer. We have work done. We have power. So these are the derived quantities we'll be looking at today. If you're going to study physics or if you have been studying physics, you will notice that the use of what? Find the volume, find the density, find the velocity, find the speed, find the impulse, find the momentum, work done. What is the acceleration? What is the velocity? All sorts of stuff of that physical quantities. So this is what we'll be looking at in this video. Then in other aspects, maybe in our series of class 2, we'll be going to other concepts. You need to take things poco, little by little, because if there's too much information, it will lead to loss of information. That's why we want to keep the information in the possible way, possible best quantity that is can be assimilated by everyone. So let's look at area. So what's the unit of area? Now area is length times breadth, which means that if you study a little bit of indices, if they say that x raised to the power of a times by x raised to the power of b, that is x a plus b. That's a law of indices. Now, if you look at this place, we have area. And I told you to look at MLT. Now, if you're talking about M, which of course, do you remember? Can you tell me mass? Then we'll talk about L, which is length. Now, notice that the length is measured in meters. Of course, time. T is time. Length is measured in meters. Now, it means that length is still talking about meters for the unit of measurement. Breadth, for you to ascertain or measure breadth, you still need to use your ruler, and that is calibrated in centimeters and meters. So, what we're going to do is that we're going to bring in this M, L times by B, that is area. We'll represent L by M, represent B by M. So 1 plus 1, that is meter squared. That's why area is always and will always be meter squared. So let's look at volume. Volume V is length times breadth times height. So length times breadth, that means meter times meter times meter, because meter is the unit of measurement for all of those, length, breadth, and height. So we have meter cube. If you use these m times m times m times n, all right, m times m times n, that's 1 plus 1 plus 1. Let me do it here. So volume is meter times meter times meter. 1, 2, 3. So it is equals to meter cube. So now let's go to the next one, density. If you look at density, density D is simply mass over volume. So density D is mass over volume. Now the unit of mass is kg, then the volume is meter to the power of 3. Do you see that? Meter to the power of 3. And in mathematics, if this one comes up, it's called the rule of negative power. When we have x to the power of -1, the same thing as 1 over x. So if this guy comes up, it will become kg meter minus, kg meter minus 3. So we have here kg, kilogram, meters minus 3. So we go to the next thing. Let me write very well. Minus 3. So we go to the next thing. The next one is velocity. Now, this guy. All these guys, area, volume, density, they are related with mathematics. So you should know the formula for area, length times breadth, formula for volume, length times breadth and height, formula for density, mass over volume. That shouldn't be a problem. But when you come to velocity, what is velocity in physics? Velocity is simply displacement or change in distance over change in time. You call it displacement or you call it change in distance over change in time. So let's use the one, anyone you could use, displacement over time. Now, displacement should be talking about meters. Displacement should be talking about meters. So we have m there, and then time should be talking about seconds. If it crosses up law of negative power, it becomes ml raised to the power of minus 1. So over here, we have ms to the power of minus 1. Let's go to the next one. Now, if there's a formula in physics you should know is velocity. You need to know what velocity is. Displacement over time, or change in distance over change in time. That's very important. I take it again. Velocity is change in distance over change in time. I take that again. Velocity is change in distance over change in time. Now let's go to acceleration. Acceleration, A, is the change in velocity over the change in time. Now, the change in velocity means we're going to bring the unit of velocity, the m, meter per seconds, and divide it with seconds. It will become meter per seconds per seconds. That will become meter per seconds per seconds. Remember, this is change in chemistry, in physics, chemistry, or maths. Change in velocity over change in time. And that will give me meter per seconds per seconds. So we go to the next guy, force. Now, you can notice the similarities between acceleration and velocity. Velocity, change in distance over time, or displacement over time. Then acceleration is changing velocity now over changing time. Now we can use the units and then find out your answer. We go to this guy, force. Before we go to solve for force, force is measured in Newton. Just know that. Force is measured in Newton, generally. But now we want to look at force in the use of these parameters like the kilogram and the meter and the seconds. That is the MLT, mass, length, and time. Mass, kilogram, length, meter, and then time, which is seconds. Now, let's look at force. Force is mass times acceleration. So force is mass times acceleration. So we say m times a. So now m is kg. Acceleration, pick it up there, is m meter per seconds per second. So this can also be the unit of force. Now, you can see where I solved the problem. Can you see that now? So now let's transfer this because of space. Let's transfer it inside here. So it means force is mass times acceleration, which is equals to kg meter per seconds minus 2. So either you call force kg, kilogram meter per seconds, or Newton. You're still correct. Let's make a demarcation here. All right. Okay, now let's go to the next one. The next one is momentum. What's momentum? Momentum over there is mass times velocity. You will ask, do we need to carry all this formula in our heads? Well, the answer is yes. Just need to find a way to know them. Know them, the formulas, and then you can flow with those solutions to the problems. Now, mass times volume, which is kg times by meter per seconds minus 1. Now, let's put that momentum there, which is equals to mass times by velocity. And then if you do that, it will become kg meter per seconds minus 1. Now, let's go for impulse. That's what it will be. This is the formula there. This is the unit there, sorry. The formulas is what we used to solve. So we have impulse. For the impulse, we don't have impulse, which is I, is equals to force times time. So let's pick the formula for force. You can say Newton times seconds. Impulse, which is I, is force times time, which can be Newton times seconds, times Newton seconds. Meanwhile, impulse cannot just only be Newton seconds, but it can also be, watch me now, force. Let's bring out the formula for force. Where is it over there? kg meter per seconds minus raised to the power of 2. I think, yeah, because force is mass times acceleration, so it's raised to the power of 2 times by seconds. Now, in indices, minus 2 plus 1, that is minus 1. So we have kg meter per seconds minus 1. So this is also the unit for impulse. kg meter per seconds minus 1. You notice what I did here? This is seconds. This is force, time. Time is seconds. Force is over there. We brought it here. And then minus 2 plus 1. That should give you minus 1. So let's go to prayer. I want you to pay attention for the one of prayer. Pressure. Pressure is force over area. So we have force over area. So now force is Newton and area is meter squared. Area, meter squared. Force, Newton. So we have Newton meter minus 2. And you know the funny thing about this thing? The examiner can ask you, which of these is the unit for area? They write this, Newton meter minus 2, raised to the power of minus 2. They will write Newton meter. They will write C. They can write Newton per seconds, Newton per seconds, and a lot of that. If you don't know the formula and you don't know how to calculate these things, you might not know that the answer is A as the unit of Newton. They can ask you the unit of any quantity we have listed on the board. So let's go to Newton. Let me solve that again. Prayer. Prayer is force over area, which is Newton per seconds, which, sorry, not seconds, meter square. This is Newton meter raised to the power of 2. Newton meter raised to the power of minus 2. Or Newton per meter raised to the power of minus 2, you remember? Now, pressure can also be force, sorry, let's bring up the force over there, which is kg meter per seconds minus 2 divided by meters raised to the power of 2. Now, 1 minus 2, that will be a minus 1. Minus 1 seconds raised to the power of seconds per seconds raised to the power of 2. Now, this is the way we solve this. If you look at the law of indices, let me clean up here. The law of indices states that when you have x to the power of a over x to the power of b, it is equals to xa minus b. So when we have m here, is 1m here, 2m here, 1 minus 2 is minus 1. So this can be, prayer is force over area. This can be Newton meter minus 2 or kg meter minus 1 and s to the power of 2. Now, let's go to the next one. The next one is work done. Work done. So what's the formula for work done? Work done is force times distance. So force is Newton and distance is meter. All right? Which become Newton meter. That's the answer. You're still correct. If you write Newton meter, you are correct. But if you decide to say that work done is, bring out the unit for force, kilogram, meters, seconds per seconds, times by meters, because we're talking about distance. 1 plus 1 is 2, so this kg, meter is to the power of 2 seconds per second. So this is also the unit of work done. Kg, meter raised to the power of 2 seconds minus 2. So I'll give you the privilege to solve for power. So work done is force times distance. So you can pause the video and try out for power. Okay, let me give you the formula for power. Power is work done over time taken. Power is work done over time taken. So go and solve for this using the solution method I gave to you, and get me the units of power. You know, power is measured in watts. You know, power is measured in joules times seconds raised to the power of 1. And then you can solve a lot. Just pause the video and try it out. But let me give you the answer. We have power. Power is work done over time taken. Have we done for work done? Yeah, work done is Newton meters. Okay, Newton meters. Then time taken is seconds. If this guy goes up, it becomes Newton meter seconds raised to the power of -1. So this can be power, Newton meter seconds -1. So we can look at power in another dimension. We can say work done. What's the unit for work done over there? kg, meter raised to the power of 2, and seconds raised to the power of -2. All divided by seconds. Now we're going to do a little bit of math. This one will be kg, meter raised to the power of 2, -2 minus 1. -2 minus 1. So what would that give me? If you have a -2 and then a -1 for it, that should give me -3. So over there is -3. So we have there, this could be this. All right. So this is all we've got for you in this video. And then we want to give you an assignment. Go find us the formula for energy and the unit for energy. The formula for potential energy and the unit for potential energy. The formula energy and the formula and the unit. Potential energy and the formula and the unit. And submit that answer on the comment section. See you in the next class. Bye for now. Thank you.